In the previous video, we saw that logistic regression does a really good job of fitting this "is the penguin an Adelie penguin" data. But it just seems sort of magical, like how do you get a function that has this sort of like jump from these points here to these points up here? So let me show you a little more about how this actually works. We still won't get into the precise definition of the function in this video. We'll get to that sometime later. So let's go back to this clf.predict. And input is what are the input features that we fit the classifier on. And it was just this bill length, mm. And so this outputs some NumPy array. And it's just like, what are the different predictions? So like this is predicted true, whereas this one is predicted false. But where do those things actually come from? So let me show you a more fine-grained example. Instead of predict, I can use the method predict_proba, okay, for predict the probability. And so how should you read this? You should read this as there are two possible classes. There's like class 0 and class 1, or class false and class true. And so for each input bill length, there are two predicted probabilities. There's the probability that it's true and the probability that it's false. And one thing I do not like so much for this predict_proba is it's sort of hard to tell at first, like which one is false and which one is true. So for example, if I scroll up, I can see that it was predicting 1 here. And this is the higher probability. This is 9.8 times 10 to the negative 1. So this is like a 98% chance. So this must correspond to 1. How can we see that? Or we can do clf.classes_. And so this is saying that here it corresponds to 0, and here it corresponds to 1. Okay, and so if I'm thinking of these numbers here on the y-axis, if I'm thinking of those as probabilities, then it's like, what is the probability that it's this is Adelie? So what's the probability that it's 1? So really the only number I care about isn't both of these, okay? This is the probability that it's 0. This is the probability that it's 1. And I only care about the probability that it's 1. And notice how these always add up to 1. So this is like 0.013. This is 0.1986. And I might have said that wrong. This is 0.013. This is 0.986. Add those up, you should get 1. So all I care about is what's in this, not the 0th column, but the first column. So let's see, let me copy this. And let me save it with the variable name a. And so we haven't worked so much with NumPy arrays, but if I want to get every row and then the first column, okay, where remember first is this one here. Okay, not the 0th, but the first. This is how I can get it. So in pandas, you would do like .iloc, but there is no .iloc for a NumPy array. Okay, so like we start with this 0.986. Okay, great. And so let's call this, how about df pred3? And now let's try plotting it again. So instead of C2, I'll call this C3. Okay, the y-axis will now be pred3, so these probabilities, as opposed to just the final prediction. I still want to use the red color, but let's change it to mark line instead of mark point. And then let's look at C and C3 layered on top of each other. And when it takes a little bit of time to load, and it shouldn't be taking any time because it's nothing difficult, then I usually click this stop execution and just run it again. Okay, and let's see how this looks. So this is looking a lot more like an actual function now. So this red curve, this represents probabilities. So for example, say this corresponds to like maybe 42 on the x-axis and 0.8 on the y-axis. So that is saying that our logistic regression model estimates that if the bill length is 42 millimeters, then it's an 80% chance that it's an Adelie penguin.